So you can share now.
Okay.
Yes, we see your presentation.
Perfect.
It's okay. So you can put it on presentation mode.
Okay, it's okay.
Perfect.
Okay.
I cut my microphone.
Okay, thank you very much, Marion. Thank you, everybody. We are coming from Radiolabs, partner of Emulradio4Rail project. We were committed to define and develop the Emulradio component of the satellite component of Emulradio4Rail platform. The Radiolabs team is composed by me, Alessandro Vizzarri, Professor Giuliano, and Professor Franco Mazzenga. Just a few words about Radiolabs Consortium. If Franco agree with him, I should leave the floor to him in order to comment very quickly these couple of slides of our consortium. Franco.
Alessandro, as Marion said before, we could wait for Professor Neri and postpone the presentation of Radiolabs to the end of the presentation. Okay, thank you, Alessandro.
Okay, thank you. What is the state of problem? Our approach was to focus on the emulation of the satellite network from an end-to-end point of view at IP level, including obviously also the IP impairments in order to disturb the transmission at IP level. How? We defined a process based on an IP-based emulation in order to provide and develop a satellite component of the entire Emulradio4Rail platform, using also a remote control web interface. This is a state of problems and achievements. From the implementation point of view, we considered the satellite transmission from the user and to the application server, from the left to the right. So we can consider these satellite network components in terms of user equipment, satellite modem connected to the terminal, satellite earth station, the satellite, of course, the satellite station from the receiver point of view, the satellite modem terminal, and the application server. These are the main components of satellite network, both in both of directions, in upstream and downstream. We consider in order to emulate it at IP level. And from the emulation point of view, we mapped the previous scheme of the satellite network into a satellite emulator at IP level. In this way, our emulator is able to emulate the transmission, the traffic at IP level, in order to have an end-to-end transmission, of course. In this way, we are able to see and to inject the IP traffic from the user device and to send it to the application server, and vice versa, of course, both if we consider the upstream and the downstream transmission. It is possible, of course, also, as I said before, to inject the following IP impairments in order to disturb, to alter the transmission according with the main IP impairments known in the literature as link bitrate, of course, in upstream and downstream, the link latency, and the packet loss. We would like to underline that the satellite IP emulator is transparent to the traffic injected, of course, by external devices. In this way, we can use a traffic generator such as at command line, for example, as Hyper or anything, or we can include also another kind of traffic generator with external device, of course. Which are the main emulator components of our satellite emulator? If if we consider this slide, the first figure in the bottom, in the first part of this slide, we can consider the satellite emulator and its component as terminal subnetwork, satellite modems, and satellite bearers, of course. This is the entire bearer part of the satellite emulator, and then the server's subnetwork. These four components are included in the satellite emulator. Of course, outside the satellite emulator, we have the device under test, the terminal, the SES device on the left, and on the right, we have the application server, for example, the RBC server. From an implementation point of view, we decided to implement this emulator on a single PC using a virtualized approach, of course, but it is possible, of course, to consider this implementation on 2 or 3 different physical PC, of course. Now we are going to describe very quickly the main features, the main scope of the single components of our emulator. First of all, we need to specify the scope of the terminals and the server subnetworks, of course. This component allows to interconnect, of course, the satellite emulator with external devices. For example, the DUT on the left, as I said before, the device under test, for example, the SES device, is running the client-side application, of course. And on the left, we can have the application server running the regular application on their server side. These components are committed to interconnect, of course, the external devices as DUT and server using the Ethernet connection, of course, and they provide to the tester the capability of defining the virtual terminals and servers. So we can consider to run application with additional traffic, for example. They can run server applications directly inside the emulator. Virtual terminals and server also allow to calibrate, of course, and to test the emulator capabilities without the presence of external DUT and servers. In particular, we used this possibility during the implementation phase and the integration with Hitachi equipments. Finally, the terminal subnetwork includes the ingress emulator router, and the server subnetwork includes the egress emulator router. If we consider the entire transmission of the satellite link and the implementation of the single components, we can have the figure shown in these slides. On the left, we have the virtual terminals VT1, VTN, using a couple of VET application functionalities provided by Linux operation system, of course. They are connected to a virtual bridge of a switch, using also an Ethernet physical interfaces on the left with eventually other equipments. These virtual terminals are connected on the right to the ingress router, able to be connected to different modem 1 to modem K, for example, to each modem for each satellite bearer. So we can consider not only one satellite bearer, but different satellite bearer at IP level. Of course, we have on the right, we have the egress router able to connect to be the other endpoint of the satellite bearer. In this way, this egress router is connected to the same scheme on the client on the left, because the egress router is connected, of course, to a virtual bridge switch and then to the other virtual terminals, VCS1, VCS2, which are the virtual server on the right. On the left, we have the virtual terminals. On the right, we have the virtual server, of course. All the interconnection, we would like to underline that all the interconnections are provided by Ethernet physical link, eventually connected to external device, but inside the emulator on a single PC, we used the VET functionalities of Linux operating system, of course. About the ingress-egress router operations, we can say that the ingress router routes the ingress packets from the device under test for the ICS router or packets from the virtual terminals to the corresponding satellite modem bearer. And as I said before, the other endpoint on the right. On the basis of the destination IP address, the ingress router routes egress packets to the device under test router to the virtual terminals, VT1, VTN. The egress router, on the basis of the destination IP address, routes ingress or egress packets to the virtual server or the virtual server VS1, VSQ, and so on. We would like also to mention this functionality provided by the token bucket flow, TBF, QA discipline, embedded in the Linux operating system, because in this way we are able to emulate also the different accommodation of the packets inside a packet queue, of course, using this approach provided by the token bucket flow of Linux. Why? Because in this way we are able to emulate the different bit rate of the terminal, both in upstream and downstream, in order to see the different accommodation of the packets, if it will happen, and also the possibility to manage additional impairments of the traffic. This is a functionality useful for us because we are able to compose different scenarios and to see different behaviors of the emulation and of the traffic between the device under test and the application server. For the single satellite bearer, which I is the index from 1 to P, for example, we can see the following scheme. On the left, we have the ingress router, and on the right, we have the egress router. Inside this link, we have three different virtual components, named with RI1, RI2, and RI3. These different components, which are the virtual component, virtual router, able to route different packets in between the ingress and the egress router, are able to emulate the single nodes of the satellite entire transmission we have seen in the previous slides. So in this way, we have the link between the RI1 and the RI2. We are able to emulate the satellite to terminal, the terminal to satellite link here, following the upstream link. The next link is able to emulate the satellite to gateway link, and the third one is able to emulate a connection, an internet connection between the gateway and the server link using a wide area network connection, if we consider the application server is located after a wide area network connection. On the left, we have the modem where we implemented the TBF, rate limiting QA discipline. This is valid for the upstream link in the first part of this slide, and the bottom we can see the same behavior for the downstream, from the egress router to the ingress router. Here we can see some results we collected during the first test of our emulator inside our lab. Here we can mention the ping command where we sent an ICMP IP ping packet composed by 64 bytes every m second. Of course, we can modify this value of m. We choose the default value of 1 second for the ping command, and we have a bit rate at IP level of 5012 bits per second. We have satellite link, characterized by the following delays. Here we have 3 different delays because we segmented the link in 3 different stages, in 3 different steps, each one for the single virtual component RI1, RI2, and RI3, as I said before. We moderated the satellite link also with a packet loss of 10%, with the hypothesis of an internet connection using a wide area network connection. And here with the TBF rates with an available channel capacity of 10 kilobit per second and the possibility to reduce it to 0.1 kilobit per second. Here we can see on the right we can see the screenshot of the test we collected, where considering the transmission without variation of internet connection, without packet loss, so we can consider it at 0%. We collected a successful ping attempts. In this way, we received, of course, all the ping attempts we performed with an average delay of this value, 6 to 1.5 milliseconds, derived by the sum of the single delays here for each stage. So this is the proof of our emulator, of course, without IP impairments, without our other disturbs of the traffic, is able to respect internally to respect the delays we set between the single virtual node. Okay, sorry. This one is another test we performed where we considered a uniform variation for the internet link. So we were interested to see how the wide area connection should contribute to disturb the transmission. So without a packet loss, of course, also in this case we received all the ping attempts with an average delay with this kind of variation with a minimum, maximum, and average delay, of course. Here we put in this third test, we put an additional packet loss of 10%, in the opposite way of the previous test. And here we can see that the results are different from the previous one because we received only 90 ping attempts to 100 ping attempts with an average delay of 6 to 3.3 milliseconds. So here the results show that with the results of the test is compliant with the test configuration we set at the beginning of the test. Regarding the final integration with Hitachi, I'd like to show the composition of our team with, as I said before, with Professor Romeo Giuliano from Radiolabs and University Guglielmo Marconi, from Franco Mazzenga, who is the technical director of Radiolabs and professor at University of Tor Vergata, and me. We, after the previous tests with which we tested the performance of our emulation internally in our lab, in accordance with the COVID emergency, we proceeded with the integration with Hitachi in a remote way. I mean that the ICS client, the ICS terminal, and the ICS server are located in Genoa in Hitachi Rail lab, and the satellite emulator is located in our lab in Rome. Here in this figure we can see the two OpenVPN connections needed to perform this test carried out in a remote way. The first VPN connection is between the ICS client to our emulator from Genoa to Rome. Here on the right we can see also the web control interface in the bottom part of this icon, where we set the value of the single path, the single three different paths from the terminal to the application server, the three segments described in the previous slides. Also with IP impairments, we can set here using obviously an IP address. The second OpenVPN connections is able to connect the return from the Emulradio, the satellite emulator, to the ICS server. That's why we needed two different OpenVPN connections. From a performance evaluation of the emulator, of all the functionalities of our emulator, we proceeded with the connectivity test, a basic test, of course, based on a ping command, which we performed in two different steps. The first one is the calibration phase, where all IP impairments are set to 0, so we are in the condition of an ideal channel. This phase is very important in order to measure the additional latency, the additional delay coming from the wide area network connections due to the remote connection, of course. The second phase is the text execution, where we're setting delays on the different path segments, both in upstream and downstream, from to and from satellite gateway to the server, and during the test execution we were able also to insert a packet loss impairment on the different path segments, also runtime. Here we can see some slides about the final integration with Hitachi. In this we also produced a video. We captured the video during the final integration with Hitachi people. We would to thank for their availability of this activity. In the frame on the left of this part of this image, we can see the Hitachi Rail Lab with the ICS Hitachi equipment, and on the right we can see our screenshot about our desktop, our web control interface of the emulator, of the Emulradio satellite link. The first step consists, of course, in measuring the RTT and round trip time of over the wide area connections. As I said before, all IP impairments are set to 0. After the calibration phase, we proceeded to execution the connectivity test in order to see if both of the previous objects, ICS client and ICS server, were able to reach our emulator in Rome. In this way, we set different, as we can see in this slide, we were able to set a different value of latency for each of the 3 different paths and the value of the packet loss, of course. Here, in the first part of this image, we are talking about the terminal to the server. In the second one, in the bottom, we can see the server to the terminal connection. Here we can see other attempts during the final integration where we we changed the value of the packet loss, so we put an additional packet loss in the first 2 stages of the transmission from terminal to server, and the same situation we have in the server to terminal transmission, where in this case we also added the third packet loss on the third virtual router. Here we can see some other values of the latencies and the packet loss of the test configuration we set, and on the left we can see what Hitachi, industrial partner or Hitachi, was able to see on the screen of the ICS equipment. About the conclusions and next steps, we can see that the emulation of the satellite networks of our emulator is provided at IP level. We are able to insert the IP impairments as traffic disturbs, and we can also provide a remote activation of the satellite emulator using the web control interface. Regarding the next steps of our work, we can consider also the possibility to extend IP emulator to other communication technologies, and also to implement statistical distributions of satellite transmissions coming from different test trials of test campaigns provided by the field trials. Thank you very much for your attention, and we are available for some questions. Thank you.
Thank you very much, Alessandro. So I don't know if there is some question in the chat. I will have a look if I can find.
Yes, there was one question, but it seems like it has been answered.
Sorry, Christina, could you repeat, please?
The question was from Fabrice Desclos, and Franco have already answered. The question was the delay you use seems to be LEO satellite. Did you achieve any simulation for GEO satellite? And Franco, if you want to answer again for everybody, it will be nice.
That's okay, Marion. No, sorry to answer to Fabrice. Maybe this could be confusing, but we have, as Alessandro has shown in our presentation, the satellite link has been decomposed into 3 parts. In particular, the upstream satellite link, for example, is composed from the link connecting the radio terminal with the satellite and the satellite with the gateway. So there are 2 links on upstream. The delay on each link is 125 milliseconds. So the overall upstream link, the delay is 250 milliseconds. If you consider also the downstream transmission, you have other 250 milliseconds, and this is the typical round-trip time over a satellite or a geostationary satellite link. But I would like also to thanks to Fabrice for his questions. In order so to put into evidence that in our emulator we can also insert the delays, for example, concerning LEO satellites or medium Earth orbit satellites. So the emulator is flexible and can be easily adapted to accommodate other, oh, thank you, Fabrice, even to accommodate other satellite technology.
Okay, thank you very much. I don't know if there is other question in the chat, or if you want to ask some question you didn't ask this morning, but we have time after for a possible discussion. So feel free. We are in time. I don't know, Alessandro, if Professor Neri is there. I have not verified.
No, but there is Francesco Rispoli, which is online, I believe, which is our general director.
Okay. So if Francesco Rispoli wants to present radio.
Oh, yes.
Okay, do you hear me?
Yes,
yes,
perfectly.
Okay, good morning to everybody. Yes, I can say a few words about Radiolabs. If Alessandro put the slides, this was just a quick introduction to present the consortium. Radiolabs is a consortium between 3 universities and 2 companies. The mission of Radiolabs is to contribute to the research, innovation, and to transfer the results of his innovation to the industrial partners. The areas where Radiolabs is more active are in the telecommunication, in particular satellite communications and 5G. Navigation systems for train positioning and vehicle positioning, and intelligent transportation systems. So if you go to the next slide, I just summarize here the major activities which are grouped in these boxes. What is important to underline is that Radiolabs is active on telecommunications and GNSS applications since 2011. So he has accumulated about 10 years of experience on that subject. The Radiolabs team is composed by 14 people. Most of them have a PhD. And in addition to these people, there are about other 15 researchers, which belongs to the 3 universities, which are partners of Radiolabs. And overall, the team is composed by 30 persons. Since 2011, Radiolabs has been involved in most of the new projects at European level. Most of them have been funded or co-funded by the European Space Agencies, and the others from H2020, and Emulradio is the last one, which was the first, by the way, project where Radiolabs was involved within the X2RAIL project. So I think that is just a brief introduction, and if you have questions, I am here to answer to you.
No, I have. I don't know if people have some question again for the scientific part, or any other question. I think I tell to every partner of the Emulradio4Rail project to present their institution, and I skip my institution and the institution of some of the participants like Gustave, Virginie, Ali, and Mohamed as is associated. So before the words of Uli from X2RAIL-3, I would like to just to present you, for those who doesn't know, University Gustave Eiffel, because it's a quite a new institution for the moment. So Université Gustave Eiffel has been created in beginning of 2020, so 1 year ago soon. It's something quite unique and experimental and pioneering, because we are the unique university at national level. And this university has been created by the fusion or merging of a well-known research institute called IFSTAR, who was involved at the beginning of the project, and existing university, a school of architecture, and 3 other engineering schools, as you can see on the bottom of the slide. So we have 17,000 students, included the 500 PhD students, 2,300 personnel, like full researcher, assistant professor, lecturer, and also an important administrative and technical staff. And we are involved quite strongly in European research and national research. And as you can see, we obtain 4 European research grants and 5 MSCA. So the spectrum of research is very wide, as you can imagine, in this very big university. What is original is that now we are located in several places in France, as you can see. The lab who is coordinating the Emulradio project is in Lille, and the north of France is a region of railway by excellence since a very long time. I'm not so young, and I'm dealing with railway since quite 30 years, since the beginning of my my career as a researcher. And perhaps on the same philosophy than Jose explained for Denmark Technical University, we have a big experience in measurement and experimentation and practical works. As you can see on this slide, we have a lot of important emulation and testing tool simulators. You can see here the Emulradio platform at IRSICA. We share a lab with our colleague of IEMN, so we are proud to be part of this big CNRS lab with them. And we have some rail traffic simulator. This traffic simulator can be connected to other simulator, and also to other identical simulator, for example, in CEDEX, in DLR, and we have a lot of collaboration with other institutions at European and international level. So it was just a few words to share with you, because I forgot to present my institution at the beginning. So I hope you appreciate all the presentation. I will leave the floor to Uli. I see he's connected, and it was a great pleasure for us to work with WP3, X2RAIL-1 and X2RAIL-3 partner. And I hope we can have more collaboration later.
Yes, for sure. Thank you, Mario. as you can see, we are sitting in the same room, Marion and myself, at least from the background, even if it's 700 kilometers
we
away.
try to be good students.
Yeah. Yes.
Lea Patis gave us for the Shift2Rail Innovation Days this background, so
yes,
I
we are
thought
happy.
it was nice to put it again.
Yes.
I don't know if Lea is there, but
I am happy to see that the background is good for you then. Good afternoon to everyone.
Good afternoon. Yeah, but Marion, what should I say? So I'm not sure if we all should be happy that the project was successful at the end, even if we had some hard hurdles in between, which I will, let's say, state afterwards, or if we should be sad because it's over and it's maybe too early over, because I think we had a very good start at the beginning. We had really very effective and very interesting workshops where we aligned at the very beginning already what we need, and you try to realize all of that what we need. And then in the last year, this virus happened, and you tried to delay, to extend the project, to have another opportunity to do the tests, but even that failed because there were so many restrictions in the different countries, so from both sides, so that there was not a chance to get together to each other. So nevertheless, thanks to Radiolabs, Radiolabs have achieved together with STS to make the integration and to show that it interworks pretty well. I've also seen in your presentation from Radiolabs that you integrated everything now on one PC. So at the beginning, I think you had 3 PCs, and now you have, let's say, merged everything on one PC, which would make life easier if we are allowed to travel again and if we can put things together, because that would have been another challenge to get your whole simulation environment to a lab. So the technical demonstrator leader were a little bit afraid, do I have enough space? But I think we would have been able to manage it. But okay, we cannot change the past, but at least all were willing to do the best, and at the end we were able to make these integrations. It would be great if this is not the end, the complete end. I think there are still some connections also going forward, as with the help of AB4Rail, so with Radiolabs, we stay in contact, but also with the emulator platform, it would be great to have a chance to use it in X2RAIL-5, as I always said in the past. I'm not sure if it's possible, and I'm also not sure if the technical demonstrator leader who finally, let's say, decide if they want to use it in parallel to the field tests to let's say verify it in the labs if they have planned to do it. But we should let's say leave the door open, and maybe if they are willing, if they need your emulators, that we will find a way to use them again. So yeah, that's I think also the vision we are going forward. So WP3, the adaptable communication system, will do an X2RAIL-5 field test. So we will try to validate what we have developed and already tested in the lab now in a real operational environment. But as we all know, if you do some tests in the field, you will find some issues, and then it would be great to have a parallel system running in the lab where emulators could help a lot, because you can much easier, let's say, stimulate specific behaviors and see how the adaptable communication system is behaving. So therefore, I still hope that there is something possible within X2RAIL-5. So thank you very much for all the work you have done in all this very difficult situation. It was a great job what you did, and I hope that we work together further in other projects or during X2RAIL-5.
Okay, thank you very much, Uli. I will now go to the conclusion of the workshop, conclusion of the project. I hope you see my screen. As you have seen, even if we were not able to go to the Siemens lab in Germany due to COVID restriction, we obtained the proof of concept of our emulation platform. I agree that it is big, but channel emulation is a big equipment. It's quite difficult to reduce this. And I don't know if open air interface can be reduced a lot because we need some resources. You have seen that it's important to have resources. If you see here, the big computer is for the EPC, and you need some resources for computing everything. We were very happy that yes, I would like to say that with this kind of platform at RF level, it is for the moment not possible to do remote integration at as Radiolab did, because if you remember, we connect the equipment to the channel emulator, and we have to connect at RF level. So if we want to go through internet or things like this, I think things will not work. It is why we have tried with the results Laurent has presented to obtain some models on some behavior of the IP metrics, the KPI metrics versus the different channels. And we have seen that we obtain quite interesting results depending on the channels. And this was one of the first questions set up in the open call, because the open call was related to how to measure or how to get the influence of the real environment in the lab. So as you have seen, it's very important to have good channel models. I think that some channel models are recognized by the international community in telecommunication in the field of public communication, but we have not a lot of recognized channel models for railways. So I hope that collaboration between the railway operator and the research can help to do this kind of work, to have tools to be able to perform zero on-site testing in laboratory. As Uli said, it is important because you cannot test everything on the tracks. It's very expensive and very time consuming, and sometimes you fail. So I think at the end of this project that we reach the goal we promised to reach, even with lockdown. It was quite difficult because the lockdown arrived in Europe at the moment where we are on the most promising moment in the project, because the colleague of DTU and Ikerlan has just starting the test. We were able to start at just after. So finally, as I told before, thanks to all the partners, we finally achieved this part. And also thanks again to Keysight, because it should, I think thanks to them, we were able to finish everything. So a success, I think, with remote integration of the colleague of Radiolab with Hitachi, with a different approach, an approach at the IP level. And since the beginning of the project, we thought that the IP level and the RF level are very complementary, and it is quite difficult to test only at the IP level for radio problem and so on. Discussion with, for example, with a colleague of SNCF have shown that they experience some problem when deploying LTE or 5G in specific railway environments. To conclude, finally, I think that we obtain a lot of results. We obtain, thanks to collaboration between Université Gustave Eiffel and Metro Madrid, we obtain a good state-of-the-art of railway channel models, and we were able to select a set of railway channel models. And we were also able, thanks to the colleague of Beijing Jiaotong Technical University, to propose a new model. And Laurent was right before. I think it's very important then to be able to have given confidence on this model. So perhaps to go on the trial site to perform some measurement, to validate some model. As we have seen with the different questions after the presentation of Juan, it is important also to have more typical scenarios, because finally in the literature we find only a small number of scenarios, rural, hilly, cutting, and perhaps they are not so representative of the location where people from railways or the railway operator encounter problems. Then we obtain also a good state-of-the-art for the possible perturbation, and to see also how to emulate them. I think this deliverable will be a good how I can say receipt book to, if you want to emulate some different kind of perturbation, as Laurent has presented. Also, thanks to the expertise of DTU colleague, we were able to emulate the load of the fixed network of the PLMN network. And we have been able to obtain some preliminary results. As I said during my presentation, we had some problems, and unfortunately we have to send back the Keysight emulator, so we were not able to investigate, to understand much better from where the errors are coming from. Thanks to the work of Mohamed and the collaboration with DTU, we obtained some results using pure simulation that are, in our sense, complementary to what we obtain in experimentation. And so finally, we have been successful in developing all the emulation platform for the terrestrial radio access technology and for the satellite technology. All the platforms are able to be controlled remotely with the graphical unit interface as a request in the call and as proposed in the project. And thanks to this long experimental assessment of the different radio access technologies, we obtain the proof of concept that our vision is working. We obtain interesting results for long tests that allow us to propose some modeling of the main IP metrics, such as jitter, bandwidth, end-to-end delay, and packet error rate. And these are the metrics that the guys who are developing the prototype for the future railway mobile communication system would like to have. And the preliminary results show that we can have some mathematical or some curves related to some railway channel. Again, we were very happy of the success of the colleague of Radiolabs, and for the integration of their emulator with Hitachi. Since the last moment, we hope that we could be able to travel to Siemens. Everything was ready. We had the plan of the lab of Siemens and so on. We organized everything. And at the end, the lockdown everywhere in Europe were there. So we have a lot of perspective. We have seen with Juan that it could be very important to have a new channel model in the FRMCS bands. They have just been allocated. You know, they have 5 megahertz in the 900 band and 10 megahertz in the 1.9 gigahertz band. So I think it's very important to continue the work. So we hope that some people will realize this. And we have seen also that if FRMCS will include the 5G system, we will need to take into account 5G signal, 5G channel models. We need to update the open air interface with MIMO. Today, we decided with discussion with X2RAIL-1 partners that the transmission will be in SISO, because their system, their prototype is working in SISO mode, but open air interface allows MIMO modes. We have tested with 2 different software-defined radio boards, and we have seen that obviously the board with FPGA work better, and we have already tested, and we are outside of the project, but as researcher we continue the work. And as I said before, and as Raoul said, they have implemented the last version of the open air interface, and it's work much better. And we are at Université Gustave Eiffel starting to work in 2021 to implement 5G if this is available, but not yet totally available, but we are in contact with EURNEXe-V. And my final word will be that the bricks of the platform are available for new projects in railway, but also in the road domain, and partners, all the partners around the table are ready to collaborate again. We discuss a lot in the exploitation plan of the project, and I think it will be very easy to set up a new collaboration. And also in the north of France here, we are investigating the possibility to set up some kind of European lab dedicated to simulation and emulation. And the Technological Railway Institute, Ralenium, is starting to build a numerical testing center in which this kind of emulation platform can find a good place among other kind of emulation platform for other topic like energy or mechanics or infrastructure and so on. So I put all the photography of the colleagues that have been working in this nice project, and I propose to show you, if you are still okay to remain with us, a small film you can find on the website of the Emulradio project just after the end of the workshop. So I don't know, Christina, you want me to show the film, or you are ready to show it?
Yes, I can show it, or you can show it. Doesn't matter. It's already on the website.
Okay, so I will show it. So I hope it will work. So I think I have first to stop and then to share again. Here. And I hope you can see something. Tell me. Okay? The Emulradio4Rail project is a European collaborative project financed in the framework of the Shift2Rail program. The partners of the project are Université Gustave Eiffel, Université de Lille, Denmark Technical University, Radiolabs, Metro de Madrid, EURNEXe-V, and EURNEXe. Université Gustave Eiffel is leading the project. Today, a new wireless communication system for control and command of trains based on radio communication is under development at European level. This new system will concern every kind of train: high-speed train, intercity, freight, regional, and metros. This system, called Adaptable Communication System for All Railways, will operate in parallel several radio access technologies. The test of a new wireless communication system in real condition on the track is very expensive and very long. New systems should be validated without expensive trials. To do so, this approach is called zero on-site testing. The Emulradio4Rail objective is to answer the challenge of zero on-site testing. To do so, we have developed a hardware and software platform for the test of new communication system prototypes. The aim of the Emulradio4Rail project is to emulate the complete link from the equipment on the train to the network on the ground, which correspond to the uplink, and vice versa, that corresponds to the downlink, and then to mimic the real radio environment with a channel emulator. The radio railway environments are very different, and the waves behave differently. This behavior should be taken into account for the system development. Mathematical channel models are obtained thanks to measurements along the track and are able to reproduce the statistical behavior of the channel. They are then implemented in specific device called channel emulator. The platform includes one satellite system emulated at IP level developed by Radiolabs in Italy, two full LTE systems developed with open air interface software, respectively by DTU in Denmark and Université Gustave Eiffel in France. The two LTE systems are frequency division duplexing. They operate in the same band. Then we have one Wi-Fi system with two independent modems, one on the ground, one on the train, operating in time division duplex, developed by Université of Lille and EURNEXe in Spain. And then perturbation can be injected with external jammers or directly in the channel emulator. Now, we will detail one open-air interface platform. Here is the dongle that mimics the user equipment in the train. The dongle is connected to the eNode B via the channel emulator. The eNode B mimics the USRP board connected to a computer and to the Evolve packet core emulated by another computer. Here we can see the IP transmission between the eNode B and the user equipment in the train through the channel emulator with a specific Illy-Terrain channel model. The project has selected a set of 5 specific channel models for railway environment, including tunnels. We have verified that each platform works correctly individually in each partner lab. a big challenge was to integrate all the bricks of the platform together in a unique location at IRSICA and to connect all of them to the Keysight channel emulator with the right setup. The next big challenge is the integration with industrial communication system prototype from X2RAIL-3 WP3 project. Then the platform will be available for testing. The platform will be then upgraded to take into account 5G deployment. It could be easily transported to automotive domain with the right channel models. I would like to thank all the partners of the project for the fruitful collaboration and the fruitful discussion. I would like to thank the X2RAIL-3 WP3 partners for the discussion, and obviously I would like to thank the European Commission for the financial support. So, thank you very much to all of you. So now we are very good in time. So if you have a question, if you want to comment, and so feel free I think we have time. You can activate your microphone and ask questions directly because we are in time.
Okay, Marion, thank you very much. I don't have any question. I just wanted to say thank you and also make a very short presentation of me because I have been silent the whole, whole time. So I'm Christina. I'm working for EURNEXe. So I will share. I don't have any presentation, but I share the website. So EURNEXe stands for the European Rail Research Network of Excellence. So we are an association sitting in Berlin and composed of 34 right now scientific institutes, all in the area of rail transport and mobility, all over Europe. And so we have been taking care of dissemination in the project. So yeah, that was all from me, just so you know.
Yes, and also website construction and update and
logo, also, website, yes, and everything and that has something.
Leaflets, and I think a newsletter is now available on the website with the last results, and then you will have the film and so on. So I don't know if Leah Patis from Shift2Rail want to speak, or a project officer, Javier, I don't remember the family name, is on paternity leave, so he was not able to be present. But perhaps Leah, if you don't mind to say 1 or 2 words on it, it will be nice.
Okay, but just 1 or 2 words then. Thanks a lot, Marion, for this. Indeed, I'm replacing my colleague Javier Ibanez, who was the project officer for most of the running of the Emulradio4Rail. But since I am the program manager for IP2, I still followed what the project was doing. Also because I'm responsible for all the X2RAIL X series project, including X2RAIL-3. Mm-hmm. No, for me, I think I will only go in the same direction as what Uli has said earlier, is that you had a challenging project with a challenging timing, challenging scope, and you dive directly into, like most of the other projects, into a pandemic. And I think being able to finish the project now and finishing the project successfully, I think it is very good and even excellent. So I think extending all my congratulations to all the consortium, And I think with everything that has been presented since this morning, clearly shows that the project has not only delivered results, but has delivered results that will be used in the future and with big added value. So congratulations again to everyone. And that's it.
Okay, thank you very much, Leah. I would like to thank again all the colleagues. It was a great pleasure to work together. Unfortunately, I think we spend more time on visios and on meeting, but we had a nice meeting in Spain, in Italy, in Lille, and in Denmark also. I think we have just missed the Madrid meeting, but because it was the lockdown. I would like to thank also the colleague from X2RAIL-3, and particularly, I don't think Lars from Siemens is there, but we discuss a lot to try to have this famous integration in Ulm, in the lab of Siemens. And I don't know if someone else would like to ask a question or to say something. We are trying now to disseminate correctly. So as a researcher, we are trying to write some paper. We have wrote some conferences, and I am trying to prepare some different papers, because I think we have interesting results to be published, and I will share with the partner. At the moment, I was pushing everyone to finish the deliverable, and I think that we will be able to submit everything before Christmas holidays, so it will be nice. And then the final report in January for the evaluation of the project. So feel free. Nobody want to take the floor?
No, we don't have nothing to add, Marion. It was a very good conclusion. You miss, personally, I miss a little bit the physical meetings. I wanted to go to Madrid, but that will be for another day.
Yes, but thank you also for your statistical analysis and some pressure.
Yes, not always for the.
It's not easy for everybody, this lockdown with lecture with Zoom and so on, who takes much more time than a normal lecture. So if nobody wants to add things, I would like to thank warmly all the attendees to this workshop. I hope you enjoy, or you appreciate the hard work we did during the project and the result obtained. Even if the last integration is missing, I think for my side that the last integration is just a question of logistics, but not a question of very complex. We have proven that the platform is working, but logistics is not a small point with a lot of computers. I would like to thank again the speakers and the participants, and that's the end. But for the partners, don't go to sleep too quickly. We have some more report to finish. Okay, so I just want to applaud everyone. And I cut the meeting.